In this video, Paulo and I will present the Scalability Explorer component developed within the Correos project. This component is part of the Rehearsal testing framework. Rehearsal is an open source framework supporting the automated functional testing of web service choreographies. It provides support for implementing unit integration and acceptance testing of web services and choreographies. But it also has the Scalability Explorer component that provides support for automated non-functional testing of web service choreographies, focusing on testing the scalability of a choreography. This framework supports test-driven development techniques for choreography development. So organizations developing choreographies may choose to use a TDD approach or not. It's optional. If they choose to use TDD, we propose a method to help them using this rehearsal framework to develop the choreography using test-driven development. If they choose not to use TDD, they can still use rehearsal to build a testing suite for verification and validation of the choreography and also for scalability evaluation of the choreography. So let's focus now on the Scalability Explorer. We have another video that focuses on the functional tests. This video focuses on the scalability tests. One can say, for example, that an application is scalable if it meets its SLA when its underlying resource usage increases in the same proportion its load increases. Another person could say that an application is scalable if it continues to meet its SLA when its load varies across its operational range. So Rehearsal provides the Scalability Explorer to facilitate the creation and execution of scalability tests to test this kind of assumptions about the scalability of a certain choreography. This Scalability Explorer is a Java framework, and it contains a mechanism to run a test multiple times automatically, increasing scalability dimensions. And it includes a template with a common scalability test where the dimensions grow step by step. A number of requests are made in each step. And the developer that's using this framework can customize this template for its specific test. Or it can decide to create a completely different template to do a completely different scalability test. But in this template that we provide initially, it has some abstract methods and some objects that can be injected into the framework and some specific attributes that can be set to customize the test. For this template, the scalability dimensions are the number of requests per minute and the quantity of a chosen resource. For example, the number of replicas of a service performing a certain role in the choreography. So this is the overall architecture of the Scalability Explorer. And we have some detailed text explaining how each of these components work, and this can be found in the Correos deliverable 4.2.2. In this case here, we'll show how this scalability tester, which is our template, can be used to exercise all the other components of the framework. So this template has a number of attributes and certain abstract methods that we implement to execute a certain test that we'll show for you. So the Scalability Explorer is a framework that has some hotspots that can be customized by the programmer. We have these method hotspots that can be implemented or not by the programmer. For example, the setup call is called at the beginning of the test, and there is where the programmer defines the context in which the test will be executed. So the test can be executed, for example, in the developer machine, or the setup can, for example, enact a choreography, deploy a choreography on a cloud computing environment. And this setup is where this initial starting up of the choreography will be executed. Then we have resource scaling, which is called in the beginning of each step of the experiment so that the programmer can adjust the new text values as the scale of the different experiments increase. Test is a method that will do the actual execution to be measured. Normally, we will test, for example, a certain use case of the choreography. So we issue the initial call to start that use case, and then measure how much time for example, measure how much time it takes to execute that use case. Also, if there's something to do before each of the calls to the test, the programmer can write the code here. And if there is a need to do some final cleanup or garbage collection in the end of the overall test, then the tear down method can be customized. Also, we have some interfaces that can be implemented to customize parts of the experiment. Scalability function defines the growth pattern for the scalability dimensions. Load generator defines how the invocations of tests will be distributed over time, if we are going to use a uniform distribution or a Poisson distribution or a completely random distribution. Executable is the component that actually makes the calls to the tests, defining what will be measured. For example, if you want to measure the latency, this is one option. An aggregation function defines how all the measurements in a step will be aggregated in a single value. For example, we can do arithmetic mean, or we can have the 95 percentile. You can define that with different aggregation functions. Then there are some certain attributes that the programmer must define. The number of steps that will be performed in the experiment, the number of executions per step, for example, the number of times the test will be executed in each step, the initial number of requests per minute that will start the experiment, the initial resource quantity that we will use, and for example, we can have a measurement limit that will define when the test will finalize, because we can define that we want to test if we meet a certain SLA. So if what we measure goes above that SLA, then we can stop the scalability test because the system is not responding well within that level, so we can stop doing the scalability test. In the deliverable for 0.2.2, we have a detailed explanation of the dynamics of all this process and how all the components of this framework, the scalability tester, how it calls the scalability test, and it interacts with the load generator, executable aggregation function, and scalability function to execute the overall test. Here, let's go direct to a live demo instead of going to the details, but the details are explained in the text. Before that, so let's switch now, Paulo, to Eclipse, where the developer would be working. So here we have, for example, one test that we already implemented. The idea here is to test the scalability of a supermarket choreography that we developed to serve as a test for us. And in the supermarket choreography, we can have multiple customers trying to buy a lot of products from a range of supermarkets. And in this choreography, there is a portal that offers the services of several supermarkets to the customer. The customer defines what it wants to buy, and the portal see what's the best price available in the market, and do a lot of calls to several supermarkets, and then to companies doing the shipping of the products to the home of the customer, and also issue calls to a credit card company to charge for the customers, and so on. So this is a complex use case involving several calls to several services. So to test the scalability of this choreography, we implement this supermarket scalability tester, which is a subclass of our scalability tester, which is that template. Then we need to implement some of those abstract methods, and here are the implementations. And then we define the attributes of our framework here in our main method. In this current implementation, we are running the choreography within the developer machine. So we are not doing a distributed execution of the choreography within this test. That would be the next step for the developer. So what we do here, we define that the initial resource quantity is 1. In this case, the resource is the number of portals that the customers will use to access the system. So we start with a single portal, and as we go from one step to the other, we add more portals. We start with 300 requests per minute, so it's like 300 different customers buying per minute some products using this portal. And we use a scalability function in this case that will provide a linear increase in the number of both resources and requests per minute. So in the first step, we have 1 portal and 300 requests per minute. In the second, we have 2 portals and 600 requests per minute. And we'll do this experiment in 5 steps. So in the last step, we have 5 portals in which 1,500 requests per minute will be made. So this is roughly 25 executions of the use case per second. So it's like we have 25 customers per second exercise this choreography, and we'll see if the current implementation of the choreography scales well up to this kind of load. In each execution, we are repeating each execution 50 times, and then we take an arithmetic mean of the execution in these 50 times, and then we'll draw here in the end. We draw a chart, a graph showing this execution. So let's run this test now. And what we see here is that in this case, we are running inside Eclipse. So the test is executing hundreds, actually thousands of repetitions of this use case that I described. And it's computing the latency, the time that it takes to execute each of the use cases and aggregating the values. And now, so it finished to execute the 5 steps. And we can see that this choreography running in a single machine with up to 5 portals and up to 25 requests per second. This is here in the case of we have 1,500 requests per minute. We still have a very good response time. So with this 1,500 requests per minute, the mean response time of the entire use case is only 67 milliseconds. So this choreography within this operational range is scaling very well. The next step now would be to change the setup function to enact the choreography on a cloud computing environment and check if deploying this choreography in the final environment in which it will be executed, if the scalability continues to be well and accepted within the SLA of this kind of application. From what we can see here, it looks like we won't have any problem running this in the actual environment, but to be sure, we must deploy the choreography in the actual production environment in which it will be executed. So this was our demo of the executing, and now we are improving this Scalability Explorer. The code is already available, but we want to do something more to improve the Scalability Explorer. First, we want to implement a runner so that the test can be configured using Java annotations instead of requiring that main method. We believe that if you do that, it will be a little easier to for the programmer to define the test, and it will give us a little more flexibility. We also are implementing support for saving and retrieving test results to facilitate comparisons among different test cases. For example, we could save the result of the testing in this machine and then compare with the production environment to see if there's any significant difference. We also doing new implementation of extension interfaces to enable more flexible tests, and we want to improve this graph to show other aspects of the tests, such as standard deviation, confidence intervals, maybe a box plot, and things like that. So we are doing these enhancements, but you can also help. Rehearsal is an open source project, and we expect to receive feedback from users that would like to use this framework to test the performance of your services and your choreographies, and maybe even orchestration can be evaluated using this testing framework. So if you want to use it, please download the code and send us feedback if you have any question, any difficulty. Also, please, you can write to Paulo Moro, and this is the email address. And we also want to collaborate with people that want to help us to improve the framework. So if you want to do some research or some production work with this framework and you need to extend it, don't hesitate to contact us, and we'll help you and provide all the support for you to collaborate with us improving the framework. The code can be downloaded either from GitHub or from the Object Web Subversion repository, so feel free to download the code and contact us.